Alright, in this video I'm going to be going over the law of sines. And in real life, we don't always have a right triangle. We can use SOHCAHTOA to solve pretty much any right triangle, but if we don't have a right triangle and we have something like an acute triangle or an obtuse triangle, something called an oblique triangle, then we're going to be needing to use something different. So we have two laws that we can use, law of sines and law of cosines. So I'm going to quickly go over how we come about the law of sines and then do a couple of examples. So the law of sines, let's take a triangle that is non-right. So let's do something like this. And in this triangle, I'm going to go ahead and label this side A, angle B, angle C. So this is side C, this is side A, and this is side B. And this is a non-right triangle. So what we're going to do is we're going to take and draw an altitude or height that's straight down. So that way we do have a right triangle. So right here, now we have a right angle. And notice here that the angle here, A, well, you know what, let's call this H, right? So angle A, the sine of A, of angle A, is going to be equal to the opposite over the hypotenuse. In this case, we're looking at this triangle here. And this triangle here has an opposite from A is A of H and a hypotenuse of B. So this is H over B. We're going to solve for H by multiplying both sides by B, and we're going to get H equals B times the sine of A. Let's do the same thing for this angle B. So for angle B, I'm going to do the exact same thing that I did over there. So I'm going to have the sine of B is equal to the opposite over the hypotenuse, in this case A. Let me solve for H, and I'm going to get A times the sine of B equals H. So notice here that H is equal to B sine of A, but H is also equal to A sine of B. So I'm just going to put these two equal to each other. So I'm going to have B sine of A equal to A sine of B. I'm going to divide the A over and divide the B over, and I'm going to get sine of A over A equals sine of angle B divided by side B. And this is the law of sines. So we can relate the angles and sides by the sine of the angle divided by the side, opposite side. And if we did this again, we'll also see that this ratio is also equal to the sine of angle C over side C. So you can set up any pair of these two ratios of side and angles and sine of the angles using the law of sines for any triangle, not just a right triangle. So let's take a look at a couple of examples here. So here's our first example. So let's draw this triangle out just to get an idea of what this looks like. So you know what I like to do? I just like to draw a triangle like this all the time. This is just a generic triangle. And I'm going to label this side A, side B, angle A, angle B, angle C. And remember that the side across from the angle is the side. So this would be little c. Well, we don't know little c, so I'm going to mark that little c. We don't know B. We don't know angle C, but what we do know is we do know side A is 14. We do know that angle B is 48 degrees. And we do know that angle A is 23 degrees. So we can easily find this angle here by adding 180 degrees. Taking these two together and subtract 180 degrees. Okay, so when we do that, we're going to get 109 degrees Okay, so angle C is 109 degrees. And now we're going to need to find side B. So we notice that we have sine of A over A. Remember, using the law of sines. Okay, the sine of A over A is equal to the sine of B over B. So I'm just going to put in this ratio here. So the sine of angle A, this is angle A right here, so the sine of 23 degrees, over side A, which is 14, equals the sine of angle B, 48 degrees, okay, we know that's given, over side B, we don't know B. Now this is a ratio, okay, it's proportions, so we're just going to cross multiply. So we're going to cross multiply here, cross multiply there. We're going to get B times the sine of 23 degrees equals 14 times the sine of 48 degrees. And then divide sine of 23 over. And then we're going to enter that into our calculator. And we're going to get 26.6 degrees. Okay, or sorry, 20.6, not degrees. It's just 26.6. All right, 26.6. All right, so we got B here is 26.6, and now we need to find C, and we're going to do C the same way we did B. So we're going to set up the sine of 23 degrees over 14, because we have this same ratio, equals the sine of angle C, which was 109, over little c. So we do our cross multiplication, and we're going to end up with 14 times the sine of 109 over sine of 23. And we're going to do that in our calculator. Okay, and that gives us 33.87. Well, we're going to go 33.9. All right, so 33.9. All right, so that's the first example. If you want to try the second one on your own and then look at the solutions, you can do that. So I'm going to go on to the next problem. Okay, example 2. So again, we're going to draw the triangle. Again, I just like to draw this generic triangle here. You can draw it any way you like. You probably don't even need really to draw the triangle, considering you're just using the law of sines. So angle A, angle C, angle B, and then you don't know the rest of them. So in order to do a law of sines, you need an angle and its opposite side. So we're going to need angle B. So let's go ahead and calculate angle B using 180 minus the sum of these two. 68.9. So we got 68.9 degrees. And then we're going to use our law of sines. So this time we're using B and B. So that's going to be our starting ratio. So we're going to go sine of 68.9 degrees over 3.8. Okay, because this is the sine of B over little b, equals, let's do A. Let's do this one here. So sine of 72.4 over little a. And then we're going to do our little bit of math here. So cross multiply. 3.8 sine of 72.4 over sine of 68.9. And that's going to give us 3.88. Okay, and then we'll do, let's see, so we got A is 3.88 inches. And now we need C, so we're going to continue to use this one. So sine of 68.9 over 3.8 equals, this time we're using C, so sine of 38.7 over little c. We're going to solve that, so little c is going to be equal to 3.8 sine of 38.7 over sine of 68.9, and that's going to give us about 2.55. Okay, so 2.55 inches. And that is how to use law of sines to solve a triangle. So I've given you some practice problems. If you're in my class, you got a couple practice problems on your worksheet. You can go and work on those, and there'll be another video link in this video, embedded in this video a little later, that you can go and check your answers for the practice problems. Okay, good luck. Bye-bye.